Hello and welcome once again to a Learning Together session sponsored by the Brosis Foundation. Just before we begin, I just want to let you know that the Brosis Foundation is an organization that is focused on helping the Russies High School in Jamaica. That's our number one priority, to help that high school. But in the process, we're creating resources that are available to all schools all over the world. Whoever wants it, it's available. So we're looking at ways and means that we can create opportunities that will help, especially young people who are in school. So these Learning Together sessions, both in English and math, are created with one intent: giving anyone additional opportunities to increase their knowledge in English as well as their skills in math. Okay? I just want to let you know quickly that on May 29th, there will be a very special function that will be held in the Bronx, New York, to raise funds for the very purpose that I mentioned: the enhancement of learning opportunities at Russies High School in Jamaica. Today, we are continuing what we started last time we were here. The last time we were here, we introduced matrices. We defined matrices. We determined how to identify entries in a matrix. We also learned what it meant to say that two matrices are equivalent. And as a result of that, we're able to solve some equations involving equivalence of matrices. Today, we're going to take it a step further. We're going to perform arithmetic operations. Now, when you think of arithmetic operations, here are the things that come to mind. We think of addition. We think of subtraction. We think of multiplication. And of course, we think of division. Those are the four major operations in arithmetic. You add two numbers, you subtract two numbers, you multiply two numbers, and you divide two numbers. But I have news for you. When dealing with matrices, you can add two matrices, but there are conditions. You can subtract two matrices, but there are conditions. You can multiply two matrices, but there are conditions. However, you cannot divide matrices. So this does not exist. So this exists, that exists, that exists, but you cannot divide two matrices. Does not exist. It's undefined, it's non-existent. Okay, so I'm glad we got that taken care of. So don't ever try to divide matrix A by matrix B. It does not exist. Okay, so then I mentioned to you that in order for you to perform addition, subtraction, multiplication, there are certain rules that must be followed. There are certain preconditions. If those prerequisites are not met, you cannot add, you cannot subtract, you cannot multiply. So my role and function today is to show us how to add matrices, how to subtract matrices, and also to introduce the multiplication of matrices. Okay, great. So let's start. The addition and subtraction of matrices follow the same rules. So I'm going to do both of them together. And then multiplication is a completely different animal. So we will do the addition and subtraction as one unit. in order for you to add two matrices or subtract two matrices, they must have the same size. They must have the same dimensions. For example, if you have matrix A plus matrix B equal to matrix C, if this is an n by m matrix, in order for this to occur, in order for you to be able to add them, this has also to be an n by m. In other words, the number of rows must be the same. The number of columns must be the same. And the result will also be n by m. Very important. They have to be the same size. Otherwise, you cannot. Okay? So whatever it is, they're the same size, and the sum will be the same size. So if this is a, say for example, a 2 by 3 matrix, you can only add this to a 2 by 3 matrix. And the result is going to be a 2 by 3 matrix. Okay? And the next thing is, of course, it's plus or minus. Either way, whether you're doing the plus or the minus, whichever one you're doing, they have to be the same size. And the next thing is, the result is obtained by adding or subtracting corresponding there it is. So they have to be the same size, 1, and 2, the results are obtained by taking corresponding entries. Say, for example, the first entry in the first matrix, add to the first entry in the second matrix, and that gives you the first entry in the result. So just add corresponding entries, and if it's subtraction, you subtract corresponding entries only. Okay? And that is why they have to be the same size, because if they're not the same size, then some entries would not have a corresponding entry in the other matrix. They all have to be consistent, all have to be the same dimensions. Okay? So now we need to look at an example. And of course, I did mention that the result, whether from the addition or the subtraction, the result will be the same size. There's no change in size. Keep that in mind. When you add two matrices or you subtract two matrices, the size of the result will be the same as the matrices that you did add or subtract. So let's do some examples. Given So here we are. I gave us 4 different matrices, A, B, C, and D. And there are 3 questions. 1, find the sum of A plus B. Find the difference between C and D. And then find the sum of A and C. Okay? So we'll do A plus B to start. And I'm going to be lazy. I'm going to go ahead and just write the result right below. A is a 2 by 2, 2 rows, 2 columns. B is a 2 by 2, 2 rows, 2 columns. So both of them have the same dimensions, same size. So yes, we can do the addition or subtraction, whatever is needed. So this result becomes A plus B equal corresponding entry. This is the first, this is the first, so that's 5. This is 1, this is 6, so that's 7. This is 2, this is -3, so that's -1. We are adding. And this is -4, this is 8, so the result is +4. So that would be the sum. This would be the sum of A and B. The sizes are the same, and the entries, corresponding entries, are combined to give us the result. Nothing complicated. So let's go for this one. C minus D. So this is a 2 rows, 3 columns. 2 rows, 3 columns. So they are the same size. So yes, we can do the subtraction. So C minus D will give me a 2 by 3. So here we go. 1 take away -2 is 3. 2 take away 8 is -6. 3 take away 9 is -6. 6 take away 3 is 3. -4 take away 1 is -5. And 7 take away 4 is 3. Again, nothing complicated. All we did was we took corresponding entries and did a subtraction. This is corresponding to that. This is corresponding to that. And we just went through step by step by step. And that's our answer, another 2 by 3 matrix. So now we go to the next example. This is matrix A. It's a 2 by 2. This is matrix C. It's a 2 by 3. So they have 2 different sizes. So therefore, does not exist. In other words, we cannot do that addition. It's not possible. So there you are. In order for 2 matrices to be added, they must be the same size. They must have the same number of rows and the same number of columns. That's it. And then you get the result by combining corresponding entries. If it's subtraction, you subtract corresponding entries. If it's addition, you add corresponding entries. If the sizes are different, there's no result. It's impossible to do the addition or the subtraction. So now we're ready to do multiplication of matrices. So in the introduction to matrices, which I did last time, we talked about the scalar. Which is which occurs if you take, for example, if I give you A, matrix A equal to 1, 6, 4, negative 2, 7, 3, and I say find find 2A. So this is what you would call a scalar multiple. It involves scalar multiplication. You just take whatever the matrix is, take the number 2 and multiply each entry, and that's the result. So in this case, it's going to be equal to, so you have 2A is equal to 2 times 1, 6, 4, negative 2, 7, 3. And the result is going to be 2 times 1, 2. 2 6s, 12, then 8, then negative 4, then 14, and then 6. So the scalar multiplication is no big deal. Scalar. Take the number, multiply each entry, you're done. Real matrix multiplication is a different story. Okay, so now let's go. Oops. Matrix multiplication. I'm going to do this by demonstrating, okay? So, if A, which is a let's use NM. So this matrix is a n by n, n rows, m columns. This is p rows, q columns. So here goes. I'm going to do it in general terms, and then I'm going to do specific terms. So if A is a matrix, and B is a matrix, and the product A times B is equal to C, if that exists, then there are certain conclusions you can draw. In order for the product to exist, then there are some things that must be true. Ready? 1, the number of columns of A must be the same as the number of rows of B. So M must be equal to P. Okay, that is the number of columns of A must be equal to the number of rows the number of columns of A must be equal to the number of rows. These two numbers on the inside, these two parameters must be equal to C must be a n by q matrix. So the two numbers in the middle must be identical, and the result is going to be an n by q, n rows, q column. That's what the product is going to be. So the question you're going to ask is, how do we get the entries in C? And the best way to explain that is by doing an example. Because with matrix multiplication, what you actually do is that you take a row and you multiply it times a column. It's row times column, row times column, row times column until you're finished. That is kind of abstract, so the best way to understand it is if I do an example. So let's go and do an example now, okay? So let's follow again. In order for the two matrices, in order for the product to exist, the number of columns must be equal to the number of rows. The two inside numbers must be identical. And the product will be take the number of rows from A and the number of columns from B. That's how you get it. And of course, if you flip the letters around, BA is not the same result. So AB and BA are not the same. Stay with me. Example. Okay, so we have two matrices, A and B. And our task is to find the product A times B as well as the product B times A if they exist. Okay, so let's go. A times B is a 2 by 2 times, this is 1, 2, 2 rows, 1 column times a 2 by 1. So look at this. So these are identical. So the result is, yes, it works. And then the result is going to be a 2 by 1. So that's going to be equal to 2 by 1. It's going to be like that. This is going to be a 2 by 1. So then the question is, what goes here? What goes here? Well, I'm glad you asked. So this position, let's call this C11, and this is C21. So this is the first row, first column. Second row, first column. So this entry is obtained by taking the first row times the first column. This entry right here is obtained by taking the second row times the first column. Second row, first column. And there's no second column So that will be the end of your multiplication. Okay, so let's do the entries here. So C11 is equal to, how do we do that? It's going to be 3 times 5 plus 1 times 6. 3 5s, 15. 6 times 1, 6. So the first entry is 21. Okay, let's go to the second entry. Here, it's a second row. Again, times B, which is the first column. So now we end up with 4 times 5 plus negative 2 times 6. So 4 times 5 is 20 plus negative 2 times 6 is negative 12. So that gives me 8. And that would be the result. A 2 by 1 matrix with 21 in this position and 8 in that position. Okay, so now we have dealt with AB. Let's go for BA. So B times A, matrix B times matrix A. Matrix B is a 2 by 1. Matrix A is a 2 by 2. We look at this, and look at this. They are different. 1, 2, they're not the same. So this does not exist. In other words, you cannot do that. Okay? So, do you think you have it now? Yes? Let's try another one. Suppose I did this. So yes, I must admit, I took an easy way out. I kept matrix A, and instead of B, I changed this to another matrix C, which is a 2 by 2 matrix. And now I want to see what the product AC compared to the product CA. Watch this. In normal arithmetic, if I gave you 4 times 5, you know that's 20. If I gave you 5 times 4, you know that's 20. So it doesn't matter which number goes first, the result is the same. Similarly, if I gave you 6 plus 2, the number is 8. If I gave you 2 plus 6, the number is 8. Again, the order is not important. Well, whenever you have these situations, if A star B is equal to B star A, in other words, A star is an operation, it's an arithmetic operation or whatever operation, but the order of your elements do not matter, then we say that that property is commutative. So you have just learned a new word, commutative. C-O-M-M-U-T-A-T-I-V-E. It's where you can switch the order, but it doesn't make a difference. Whoever is on first, it doesn't matter. It's just like if you're talking about a couple, a pair going to a party. John and Susie is the same couple as Susie and John. They're the same two people. So that's one couple. Okay? So that's commutative. Okay. So we are going to check to see if matrix multiplication is commutative. Now, I could easily tell you, but it's not the same. Let's find out. So, A times C. This is a 2 by 2. This is a 2 by 2. So these two, we say that they make a pair of glasses where the two lines are the same. So now you have a smiley face. And of course, these will be the dimensions of the result. Okay? So let's call the result D. And D is going to be a 2 by 2. Okay? So now, D is going to be D11, D12. Notice first row, first column, first row, second column. And this is going to be D12. Sorry, I lied. This is the second row, first row, second row. So this is the second row, first column. Then D is 2, 2. So those are our entries. First row, first column, second row, first column, first row, second column, second row, second column. So now we're going to find these numbers and plug them in. So let's go. First row, first column. First row, first column. So I could do this mentally and get my result, but just for the purpose of illustration, I'm going to write it out, and you write it out until you get comfortable. You don't need to write it out anymore. So D11 is equal to 3 times 2 plus 1 times -7 is equal to 326. 1 times -7. So now we end up with -1. D, I like to go across and get it up the first row. So D1, 2. So it's first row, second column. First row, second column. So it's going to be 3 times 5 plus 1 times 6. 3 5s 15 plus 6 equals to 21. So now we already have 2 entries. 2 entries down, 2 to go. So we go, can I go down one more line? Yes, I can. So D21. Is it visible? No, it's not visible. So I'm going to erase this. Okay, so D21. So now it's the second row, first column. Second row, first column. Second row, first column. So it's going to be 4 times 2 plus negative 2 times negative 7. 4 times 2, negative 2 times negative 7. What do we get? This is 8. This is 14 equal to 22. And then we go to the last entry, the second row, second column. Second row, second column. Second row, second column. So it's going to be 4 times 5 plus negative 2 times 6. 4 times 5, 20. Negative 2 times 6, negative 12. So our product, AC, is negative 121, 22, 8. So I'm going to write that somewhere. I am going to write that somewhere so we have it. So when we do the reverse, we can compare to see if we get the same answer. So the result is negative 1, 21, and 22, 8. Okay. So here it is right here. This is it right here, okay? Negative 1, 21, and 22, 8. Okay. So now I'm going to make some space and do this all over. Okay, so now we are talking about C times A. So C is 2 by 2. A is 2 by 2. So therefore, these two are identical. So we can, and it's the same thing, the result is 2 by 2. So we know we can get the product, okay? So let's go. So D11 is going to be equal to, so we're going to take, so C is going to be first. C is first, and then A is second. So it's the first row times the first column. So it's going to be 2 times 3 plus 5 times 4 equal to 6 plus 20 equal to 26. From the very beginning, we have a different number because before we had negative 1, now we have 26. So right away we are off to a difference immediately. 2 times 3 is 6. 5 times 4 is 20. 6 plus 20, 26. Let's try the next entry. D12. So it's the first row times the second column. First row times the second column. So it's going to be 2 times 1 plus 5 times negative 2. 2 times 1 is 2. 5 times negative 2 is negative 10. Negative 8. And we will clean the board so we can have space for the other two entries. So we are finished with the first row. And now we're going to go to the second row, -6, -7, 6. So now it's D, 2, 1. Second row, first column. So it's going to be -7 times 3 plus 6 times 4. -7 times 3, -21. 6 times 4, 24. So we realize that this is going to give us +3. And finally, D, 2, 2. So it's the second row, second column. It's going to be equal to -7 times 1 plus 6 times -2. So let's go -7 times 1, 6 times -2. -7 times 1 is -7. 6 times -2 is -12. -19. So these are the results. -1, 21, 22, 8. -26, -8, 3, -19. So night and day. So what is the conclusion? Well, the conclusion is that matrix multiplication is not commutative. Matrix A times matrix B does not necessarily have to be the same as matrix B times matrix A. Okay? So we have done 2 examples. And now I need to do one more, but this time I'm not going to be writing out everything the way that I did before. So we're going to look at another example. So we're going to do one a little using mental math and see if you could stay with me. Okay? Okay, find PP. Okay, let's try that. So we have matrix P and the matrix Q. First assignment is to find P times P. So P is equal to 3, 1, negative 2, 5. 3, 1, negative 2, 5. So this is a 2 by 2. This is a 2 by 2. So we realize we got our smiley face. So yes, it works. And the result is also going to be a 2 by 2 matrix. Okay. So this is the 1, 1, 1, 2, 2, 1, 2, 2. I'm just putting this in there for your benefit, okay? So it's the first row times the first column. First row, first column. 3 times 3, 9. 1 times negative 2, negative 2. 9 take away 2, 7. I promise you, if you roll it out, you will get the same answer. Remove these so that they don't create any confusion. Okay, so now it's going to be the first row times the second column. First row, second column is right here. So 3 times 1, 3. 1 times 5, 5. 3 plus 5, 8. So now this is the second row times the first column. Negative 2 times 3, negative 6. 5 times negative 2, negative 10. Negative 6 plus negative 10, negative 16. Again, second row, second column. Negative 2 times 1, negative 2. 5 times 5, 25. Negative 2 plus 25. So that takes care of our first product. Okay, so now let's go for PQ. If it exists. Product P times Q will be equal to 3, 1, negative 2, 5 times 1, 4, 6, 8, negative 3, 0. So this is a 2 by 2. This is a 2 by 3. So these two numbers are identical. So therefore, we can do the multiplication. The matrix product exists. So we're going to end up with a 2 by 3. So now we need a 2 by 3. So we need 6 entries to make the 2 by 3. So it's going to be the first row times the first column. 3 times 1, 3. 1 times 8, 8. 3 plus 8, 11. And it's going to be the first row, second column to get this. And first row, third column to get that. Here we go. 3 times 4, 12. 1 times negative 3, negative 3. 12 take away 3, 9. Okay? So then go to the next one. 3 times 6, 18. 1 times 0, 0. 18 plus 0, 18. Now we are into the second row. So it's going to be the second row, first column. Second row, second column. Second row, third column. Let's go. Negative 2 times 1, negative 2. 5 times 8, 40. Negative 2 plus 40, 38. Second row, second column. Negative 2 times 4, negative 8. 5 times negative 3, negative 15. Negative 8 plus negative 15 is negative 23. And finally, negative 2 times 6, negative 12. 5 times 0, 0. Negative 12 plus 0, so that would be the product P times Q. So now we're ready to go for the third example, Q times Q. Okay, here we go. Q times Q. It's going to be equal to 1, 4, 6, 8, negative 3, 0. 1, 4, 6, 8, negative 3, 0. So this is a 2 by 3. This is a 2 by 3. So this is a 3, and this is a 2. So the product does not exist. In other words, it's impossible to multiply this. So this is a row, so it's 3 things. This is 2. So you go 1 times 1, 4 times 8, 6 times, there's nothing to multiply the 6. So it's confusion. That's why it doesn't work. Okay? So let's review what we did today. The first day we met, we spoke about the definitions, key definitions for matrices. We know that matrices, a matrix is an arrangement, it's an array of data or information in rows that go across and columns that go vertically. Rows are horizontal, columns are vertical. So whenever you see the dimensions of a matrix, they always give you the number of rows first and the number of columns second. So then we also discussed that the entries or the elements in a matrix are positional. Positional. So if you have matrix A and you also use uppercase letters for matrices, to name matrices, you use uppercase letters. But for the individual entries within a matrix, you use lowercase letters. So for matrix A, if I say to you, what is the A32 entry? It means that in matrix A, what is the entry in the third row, second column? It's always row followed by column, row, column, always, always. Okay? We discovered that we can also do equivalence of matrices. We discovered that if 2 matrices, let me erase this. we discovered that if matrix A is equal to matrix B, then we know that these two must be the same size. They must have the same number of rows, same number of columns. If this is P by Q, then this has to be a P by Q. The number of rows must be the same, the number of columns must be the same. And if they are equal, then elements or entries in the corresponding positions will also be equal. In other words, what is in the 2-1 entry in A must be the same thing in the 2-1 entry in B. Otherwise, they're not equivalent. Okay? So then today, we studied about arithmetic expressions, or sorry, arithmetic operations with matrices. We talk about addition, we talk about subtraction, we talk about the scalar multiplication of matrices, and then we talk about regular matrix multiplication. We discovered that you can add or subtract two matrices only if they have the same dimensions, if they have the same size. That is, both matrices have the same number of rows and the same number of columns. If the number of rows in one is different from the number of rows in the other, you cannot add them, you cannot subtract them. Okay? And we discovered that the result of the sum or difference of two matrices will have the same size as the matrices that you're adding or subtracting. The size will never change. Then we came to scalar multiplication. The scalar multiple of a matrix is obtained by taking every entry in the matrix and multiplying by that number that's outside the matrix. That number is called a scalar. It's just a regular number, and it's not in square bracket or parentheses. Oh, by the way, I should let you know that you use, if I gave you the matrix A equal to 1, 2, 5, -3, you can use both square brackets and also parentheses. So it's just a matter of style. Both parentheses and square brackets are used to refer to matrices, okay? Or to denote matrices. Good. So that was a scalar multiple. We discovered that matrix division, you cannot divide one matrix by another matrix. That does not exist. That's undefined. And then finally, matrix multiplication. That is, in order to multiply two matrices, there are certain conditions that must be satisfied, okay, to get your result. We discover that if these are two matrices and we can multiply them, then if this is an M by M matrix, then this must be an M by P. In other words, all that's necessary is that these two must be identical. The two in and inside numbers must be identical. If they are not identical, the product does not exist. And we discovered that if that's equal to C, then we discovered that the size of the resulting matrix is going to be N by P. And then we discovered that each entry in the product is obtained by taking rows times columns. Rows from A, columns from B. Rows from A, columns from B. That's what we get the result for C. Thank you so much for joining us for another Learning Together session sponsored by the Brosis Foundation. I truly trust that you learned something today, that your mind was stimulated. Yeah, that's the word I'm looking for. Your mind was stimulated and you start to understand how matrices can be used for arithmetic operations. Okay? Again, We have many sessions in math as well as English. Tell your friends, tell your family, let them know it's free. Help yourself. All these resources are created to provide additional help for those who might find them useful. So on behalf of the Rusty's Brosis Foundation, we thank you for tuning in to us and with us and joining us in this Learning Together session. I will remind you that on May 29th, there will be a fabulous blue and white occasion in the Bronx, New York, which will involve a fish fry and a jerk chicken fete to raise funds to buy tablets for the Rusty's High School in Jamaica. What a great worthy cause. If you can make it, it's on May 29th. And if you go to the Rusty's Brosis Foundation website, you will get all the information. Thank you so much for joining us. Enjoy the rest of the day.